Hello everyone, my name is Mariane Neiva and under the supervision of Odemir Bruno, today I'm going to present my PhD project named Compose to Classify, an approach to pattern recognition in complex networks. First, I would like to give you an outline of this presentation. I'm going to introduce you the complex networks theory, and then I'm going to present you three of my approach and their results. So first, the complex networks is a set of nodes connected to each other. Node represents elements and they are connected according to a certain relationship. As an example, we have the connection of cities using the flight airlines. Also, we have a very classical example of complex network. We've been talking about the social networks, which provide us the study of transmission of diseases like COVID. This is a very interesting application to study. Why is that so important to study complex networks? If you could remember when you were a child and your professor would told you to consider a complex system as a point, we had the reductionist approach. Now with complex networks, we can study a single element as a result of their neighbors. For COVID, for instance, the connections are very important. When you can provide a complex network to improve the context, enriches our analysis. Now that we gave a motivation about complex networks theory, let's understand how we can develop the analysis in computer science. Now that we have Python, we can access several libraries and to work with complex networks such as iGraph. However, another interesting way to work with complex networks are by analyzing their adjacent matrix. An adjacent matrix is a correspondence one-to-one to nodes and links in the complex system. So here it's easy to see that this woman, she has two connections by looking to the image or to the matrix. We can look to her line and to her column and check their neighbors. However, can we find patterns in this type of distribution? Here we can find that there are several ways of writing this matrix, and all of them represents the same network. How can we rearrange the columns and the rows in order to find patterns? This is my first approach for this presentation, which is order the adjacent matrix based on centrality measures. We tried to sort the rows and the columns according to the degree. Here we have two examples of the same class, Barabasi, and they provide us the same patterns, the same distribution of connections in the image. Also, we can see here that it's possible to distinguish between two classes of networks with this approach. We can see that Barabasi has a totally different distribution of connections than what type of network. Another addition is the Erdős class. Again, we can see that Erdős has a more random distribution than Barabasi and Watts. As we have the visual analysis of the approach, can we check numerically if the classification of these images are good or not? So we use these images as input for LBP path descriptor, and we also applied KNN on the result of LBP. The results are very good, and we can see that for synthetic scale-free dataset, we have 98% of accuracy with very low standard deviation. For a synthetic data set with noise, we have almost 100% of accuracy, And for AIDS dataset, a dataset from TU, we have 98% accuracy, and for Kingdom dataset, we have 93%. So all of them, we have results over 90%, which is really good. Our second approach, which is actually, it's going to be a combination of the first one and K-Cliques. My previous background, my master degree, was based on multi-scale analysis of image. And I was thinking, how could I bring this study to complex networks? That's why I thought of decomposing the network and looking the network locally and globally. One of the approaches I'm looking at are the K-Cliques. K-Clique is a network where all the elements have K-1 connections. So here is a 2-clique. They have, all of them have one link. However, we can decompose a bigger network as a set of clusters where each one of these clusters represents a K-clique. For example, here we have 3 clusters where each one of them have 3 cliques. All of the nodes have at least 2 links. Okay, so how can I connect the K-clique and the ordered matrix? As we can see in the matrix, we have a relationship among each one of the nodes. So here is yes or no if they are connected or not. So in the K-clique approach, I had to find a correlation that could give me a number based on the relationship of 2 nodes. Here, the idea is to think how many clusters do they share based on all values of K. So if I evaluate K from 1 to 10 and 2 nodes share 3 clusters inside this group, I can have a value between them of 3. And this is going to give me, for each pair of nodes, correlation based on K-cliques. So here we have our ordered matrix, where we have in the first row and the first column the node with the highest degree, and then we can base it on the correlationship of how many clusters in common each one of the pairs have. We have now not a binary image like in the first approach. We have a colored image with more information regarding the connections. So the results are also very interesting. We have 91.4% for the synthetic scale-free data set. For the synthetic data set plus noise, we have 91.6. For AIDS, the TU data set, we have 97.1%. And for Kingdom data set, we have 92.5. Notice that the results are worse than the previous one, so we are still developing this approach. We also applied LBP descriptors in the images and used KNN for classification. Furthermore, we are developing K-cores decomposition, and we are looking for correlation between nodes, like we developed in K-Cliques. We tried K-Plex for the composition, but it's too slow, so I'm still working on this, thinking about how we can improve and use this type of decomposition. For K-Cliques, as we saw, the results are still worse than the simple ordered matrix, and we're still trying to find different approaches where we can change the type of correlation and improve combined results. And for classification, we're just using KNN. However, we are working also with deep learning to also improve the results. I hope you enjoyed the presentation. Any questions, you can send an email to me. Any ideas, I would like to collaborate and to improve this project. Thank you so much, and see you on Wednesday.